Hello, this is Mr. Zanaletto again. I'm going to talk a little bit about 11J today. It's talking about the perpendicular bisector theorem. And perpendicular bisector theorem simply says if a point is on a perpendicular bisector, then it is equidistant from both of the segment endpoints. So they have a drawing there. They also have angle bisector theorem, says if a point is on the angle bisector, then it's equidistant from the two sides of the angle. So let's consider that, look at it, sort of see what it means, hopefully bring some little better understanding of it. I don't know, there's not a lot to be said about this. I went ahead and used my construction knowledge to go ahead, and you can see my my arcs there that I made to create the perpendicular bisector. So if you go ahead and you make, since it is a perpendicular bisector, we have segment AB as sort of the main thing going on here. We'll go ahead and name this point M because it's the midpoint of that segment. That's sort of the centerpiece or the center of what our discussion is here. And once you have that, we can go ahead and randomly name another point on that perpendicular bisector. We'll go ahead and call this, I don't want to be too long, but I do want to give us a good chance to have a nice reading here. We'll go ahead and call this point P. So now PM is my perpendicular bisector to AB. And with that, knowing that, this point that's on this angle bisector should be equidistant from both the endpoints. So I'll go ahead and measure those in just a second, but let's go ahead and create them first. Connect P to the endpoints. And then look at how long is that. That looks like it's about 2 7/8. Between 2 and 7, about 2 7/8. So I would say that's 2 7/8 inches long. And then if I look at this, I get this to be 2 7/8 as well. So sure enough, it's appearing as though that worked for that point. We'll go ahead and create, now this was a 4-inch segment that I made. This is 2 7/8, this is 2 7/8. Let's go ahead, instead of just going just outside those intersection points, let's go just inside. And I'll name it like I did on my notes, N. And I'll connect those to the endpoints. N to the endpoint A, and N to the endpoint B. And with that in mind, this is about 2 7/16. 1, 2, 3, 4, 5, 6, 7/16. Just about 2 7/16 inches long there. Let's look at this. I'll go more point to point. My line wasn't exactly on there. And that is 2 7/16. So sure enough, the theorem there that says that this is supposed to be congruent to this appears to be so, and this appears to be congruent to this. So in fact, the mid-segment theorem, perpendicular bisector, not mid-segment theorem, perpendicular bisector theorem, this perpendicular bisector, which is right here, is equidistant from the two endpoints. These being the two endpoints, here and here. And the perpendicular bisector is really going straight down the middle here. And it's That's the perpendicular bisector of this segment right here. There. So hopefully that gives you some better perspective of the perpendicular bisector theorem. That's what that's really telling you. As far as angle bisector, again, I constructed, before I made the video, I constructed this angle and I made a perpendicular bisector. I made my arc across and put my 2 points and drew that. Now that I have that drawn, let's look to see if I make a perpendicular to this point, and this is going to be, making the perpendicular probably wouldn't be hard to freehand, but if we really want to make a perpendicular line to that point off that line, we can do it that way. And then I'm going to go ahead and I have plenty of room out here. I'm not sure you can see it, but I want to make sure that this and this, well, I'm going to use my ruler, my straight edge. There we go. That's a perpendicular bisector of this segment, which happens to go through that point. Doing the same thing here. I'll try to create a perpendicular through there. I'm going to go ahead and go out here and mark this and mark this, just in case I ran out of room. I went ahead and made sure that, okay, let's see how well this comes together. Ah, perfect. And there we go. So we have our 2 perpendiculars. Let's get back to around here. Now I've created my 2 perpendiculars to the sides. Let's see the lengths, because that's what they said. They said these 2 lengths would be the same. Let's see if these 2 lengths are the same. Just under 2.5 inches. I'm going to call it 2.5 inches, but remember it was just under. And then measure this, and again, just under 2.5 inches. So yes, we can rest assured that an angle bisector will have these lengths. If these are perpendicular, this length should be the same as that length given the point on the perpendicular bisector. So that point on the angle bisector, on the angle bisector. Let's keep this straight. We're talking about angle bisector theorem, and we're saying that this point on the angle bisector will be equidistant from the 2 sides. And that's what's happening there. Here, on the perpendicular bisector, it was equidistant from the 2 endpoints of the segment. This is equidistant from the 2 sides of the angle. And again, looking over those notes, make sure you have those down. But both of these theorems give us congruent segments, one from the opposite, on the perpendicular bisector at one point there will be equidistant to the endpoints. Here, any point on the angle bisector will be equidistant from the sides of the angle. And those sides, the distance from a point out to this would be on its perpendicular. That's why I went to the trouble of creating the perpendicular through that point to that line. So, hope that helps a little, and have a good day.